So you want to learn how to code, that's great. But what does coding or programming even mean? Think of it like this. A computer is a very powerful but very dumb machine. It can do amazing things, but only if you tell it exactly what to do, step by step. Programming is the act of writing those instructions. You write these instructions in a special language the computer can understand. These instructions are called code. A set of instructions to perform a task is called a program. It's like writing a recipe for a computer to follow. Instead of baking a cake, you might be calculating numbers, or creating a game, or organizing your files. There are many programming languages out there. Java, C++, JavaScript. So why should you start with Python? The main reason is simplicity. Python was designed to be easy to read and write. Its syntax, like the grammar of the language, is clean, and looks a lot like plain English. That means you can focus on learning programming concepts, logic and problem solving, rather than getting stuck on complicated rules and weird symbols. You'll write your first simple programs much faster in Python than in many other languages, which is incredibly motivating when you're starting out. Another huge reason to pick Python is its versatility. It's used by professionals at big companies. Google, Netflix, NASA. You can use Python for almost anything: build websites, create artificial intelligence, analyze scientific data, automate the boring stuff on your computer. The skills you learn today aren't just a stepping stone, they're the foundation for a wide range of exciting future projects. Python has a massive community of users too. If you ever get stuck, help is just a quick search away. Finally, learning Python opens up a new way of thinking. It teaches you to break big problems into smaller, manageable steps. This is called computational thinking, useful beyond coding. When you write Python, you begin to see the world as logical steps and conditions. It can be a fun and rewarding puzzle. You give the computer a command, and it does exactly what you say. When it works, it feels like magic. When it doesn't, you become a detective, finding the bug. Python makes the whole process accessible and enjoyable. Every great tool has a story, and Python is no exception. Python wasn't created by a giant corporation in a sterile lab. It was a passion project started by a Dutch programmer named Guido van Rossum in the late 1980s. He wanted to create a language that was both powerful and easy to read. He was working on a new operating system and needed a scripting language that could bridge the gap between complex system calls and simple shell commands. He named it Python, not after the snake but after the British comedy troupe Monty Python's Flying Circus. This choice tells you a lot about the language's philosophy. Programming should be fun and accessible. The first version of Python was released in 1991. From the very beginning, its core philosophy was clear. The Zen of Python, a set of 19 guiding principles, emphasizes readability, simplicity, explicitness. One of the lines from this document is, "Readability counts." This means that code is read more often than it is written, so it should be clear and easy to understand. This focus on clarity is what makes Python so different from other languages of its time, which often required complex and cryptic syntax. Guido van Rossum remained the project's benevolent dictator for life for many years, guiding its development and ensuring it stayed true to its original vision. Over the years, Python grew from a hobby project into a global phenomenon. Two major versions have shaped its journey: Python 2, released in 2000, Python 3, released in 2008. Python 3 was a significant update that fixed many of the inconsistencies of the earlier version. While it made the language better, it wasn't backward compatible, meaning Python 2 code wouldn't always run on Python 3. This created a split in the community for a while. However, as of today, August 21st, 2025, the world has firmly moved to Python 3. All new projects are started in Python 3, and support for Python 2 has officially ended. So as a beginner, you only need to worry about learning Python 3. Today, Python is one of the most popular programming languages in the world. It's the engine behind Instagram's backend. It's the brains in self-driving cars. It's the tool of choice for data scientists analyzing market trends. Its extensive collection of libraries, pre-written code that you can use in your own programs, makes it incredibly powerful. Want to work with data? There's a library for that, like Pandas. Want to build a machine learning model? There's a library for that, like TensorFlow. This vast ecosystem means that whatever problem you want to solve, someone has probably already built a tool in Python to help you get started. Before you can start telling the computer what to do, you need to install the translator, the Python interpreter. This program reads your Python code and translates it into instructions the computer's hardware can understand. Installing Python is straightforward. Many computers come with Python pre-installed, macOS Linux. Make sure you have the latest Python 3. Visit python.org, the official source. On python.org, open the download section. The site usually detects your operating system, Windows, macOS, Linux. It will suggest the latest stable version. Click Download Python 3.12.1. The installer file will download to your computer. Windows, it will be a .x file. Mac, it will be a .pkg file. Find the file in your Downloads folder and get ready to run it. Windows, double-click the installer file. An installation window will pop up. Find and check Add Python to Path. Make sure it's checked. This lets Windows find Python so you can run it from anywhere. Click Install Now and follow the on-screen prompts. The installer will do the rest. Mac, double-click the PKG and follow the installer's Continue and Agree prompts until it's done. How do you know if it worked? Check using the command line. Windows, open the Start menu and search for Command Prompt. PowerShell. Mac, open Applications, then Utilities, then Terminal. Once you have the black window open, type Python -- version, that's 2 dashes, and press Enter. You should see Python 3.12.1 printed back at you. If you see that, congratulations. You have successfully installed Python and are ready to write your first program. Every programmer's journey begins with a single traditional step, making the computer say, "Hello world." It's a simple program, but it proves that you have everything set up correctly and that you can make the computer do something. To write and run Python code, you need a place to type it. Python comes with a very simple program called IDLE, which stands for Integrated Development and Learning Environment. You can find it by searching for IDLE in your computer's applications. When you open IDLE, you'll see a window with a prompt that looks like 3 greater than signs. This is called the Python shell, and it lets you run single lines of code immediately. Let's try it out. At the prompt, type the following line of code exactly as you see it here, and then press the Enter key. Print, "Hello world." As soon as you press Enter, the shell should respond by displaying the text, "Hello world," on the next line. You just wrote and executed your first piece of Python code. The print part is a function, which is a pre-packaged command that does a specific job. In this case, its job is to display whatever you put inside the parentheses on the screen. The text inside the quotes, "Hello world," is called a string. It's just a sequence of characters that you want the program to treat as text. While the shell is great for testing single lines, most programs are made of many lines of code. For that, you need to write a script file. In IDLE, go to the File menu and select New File. This will open a new blank window. In this new window, type the same line of code again. Print, "Hello world." This time, when you press Enter, nothing happens. That's because you are editing a file, not running commands in the shell. You are creating a script, API file, that you can save and run whenever you want. Now let's save and run your script. Go to the File menu in the editor window and choose Save. A dialog box will pop up asking for a file name and location. It's a good practice to create a special folder for your Python projects. Name your file hello.py. The .py extension is important. It tells the computer that this is a Python script. After saving it, you can run it. In the same window, go to the Run menu and select Run Module, or just press the F5 key. The main IDLE shell window will come to the front and you will see your Hello World message printed there. You have now written, saved, and run your first complete Python program. Programs would be pretty boring if they could only display fixed text. To do anything useful, a program needs to work with information that can change. This is where variables come in. A variable is like a labeled box where you can store a piece of information. You can put something in the box. You can see what's inside. You can replace what's inside with something new. In Python, you create a variable by giving it a name and using the equals sign to assign it a value. For example, you could write message equals hello Python learner. Now the text is stored in a variable named message. Once you have a variable, you can use its name in place of the value it holds. Let's go back to our print function. Instead of printing the text directly, we can print the variable. Try this in the IDLE shell. First, create the variable by typing message equals. This is stored in a variable and pressing Enter. Nothing will be displayed yet. Now, on the next line, type print message and press Enter. The computer will look inside the message variable and print out the string that it finds there. You can change the value of a variable too. Try typing message equals, now I am storing something else. Then print message again. The new text will be displayed. The information you store in variables comes in different kinds, or data types. The most common ones you'll encounter at first are strings, integers, and floats. Strings, they're just text and you always enclose them in quotes, either single or double. Integers, whole numbers like 10. Integers, -5. Integers, 0. Floats. Numbers with a decimal point, 3.14. Floats, -99.5. Python is smart enough to figure out the data type on its own when you create a variable. For example, if you write age equals 30, Python knows age is an integer. If you write price equals 19.99, Python knows price is a float. Understanding data types is important because they determine what you can do with a variable. You can perform mathematical calculations on numbers but not on strings. Apples equals 5, oranges equals 3. You can write total_fruit equals apples plus oranges and print total fruit, which will display 8. But what happens if you try to add a number to a string, like print, my age is plus 25? You'll get a type error because Python doesn't know how to add text and a number together. This is a common bug for beginners. You have to explicitly tell Python to treat the number as text first, which we'll see how to do later. So far our programs have been a one-way street. We write the code and it displays a fixed output. A truly interactive program needs to be able to get information from the user. In Python we can do this using the input function. It's a bit like the opposite of the print function. When your program calls input, it pauses and waits for the user to type something into the console and press enter. Whatever the user types is, then returned by the function as a string, which you can store in a variable. This lets your program ask questions and use the answers to do something interesting. Let's build a simple program that greets the user by name. Open a new script file in idle and type these 2 lines. First, we'll ask for the user's name and store their answer. User_name equals input. What is your name? The text inside the parentheses is the prompt that will be displayed to the user. On the next line, we'll use an F string to create a personalized greeting print. Hello, user_name, nice to meet you. An F string is a special kind of string in Python that lets you embed variables directly inside it by putting them in curly braces. It's a clean and easy way to format strings. Now save this file as greeter.py and run it. When you run the script, you'll see the prompt, "What is your name?" appear. The program will wait, type your name and press enter. As soon as you do, the program will take what you typed, store it in the user_name variable, and then immediately print the personalized greeting. This simple 2-line program demonstrates the fundamental cycle of interaction. Prompt the user for input, process that input, provide some output. This is the core of many applications, from simple calculators to complex web forms. You are now having a conversation with your computer. One important detail to remember is that the input function always gives you back a string, even if the user types a number. Let's say you want to write a program that calculates the user's age next year. You might try something like this. Age_str equals input, how old are you? Next_age equals age_star plus 1. This will cause a type error because you can't add the number 1 to a string. To fix this, you need to convert the string to a number. You can do this using the int function. The corrected code would be age_str equals input, how old are you? Age_num equals int, age_str print. Next year, you will be age_num plus 1. This process of changing data types is called typecasting. Programs get really powerful when they can make decisions. They need to be able to check if a certain condition is true and then take a different action based on that check. This is done using if statements. An if statement checks a condition, and if that condition is true, it executes a block of code. The conditions themselves are built using comparison operators. These operators let you compare values. For example, double equals checks if 2 values are equal. Exclamation equals checks if they are not equal. Greater than checks if the first is greater than the second. Less than checks if it's less than. Let's write a program that tells a user if they are old enough to vote. In many places, the voting age is 18. So, the condition we need to check is if the user's age is greater than or equal to 18. In a new script file, we first get the user's age and convert it to an integer. Age equals int, input. Please enter your age. Now comes the decision part. We write, if age equals 18. Notice the colon at the end. This is crucial. The code that should run if the condition is true must be indented on the next line. So you would write print, you are old enough to vote. The indentation, usually 4 spaces, tells Python that this line belongs to the if statement. But what if the condition is false? Our current program would just end without saying anything. We can add an else part to our statement to handle this case. The else block runs only when the if condition is false. Example code, if age, =18, indented, print, you are old enough to vote, unindented else, indented print, you are not yet old enough to vote. Now the program gives a clear response in both cases. This if and else structure is a fundamental building block for controlling the flow of your programs. You can combine conditions using logical operators like and or. For example, let's say a theme park has a ride for people who are at least 12 years old and at least 140 centimeters tall. Your code might look like this. If age =12 and height =140, print, you can go on the ride. The and means both conditions must be true. The or operator is true if at least one of the conditions is true. By combining variables, operators, and conditional statements, you now have the tools to write simple programs that can take input, process it, and make decisions. This is the real beginning of programming.